There is a number printed on the oil fill cap of every GM truck with a 5.3-liter V8 built after 2014. That number is 0W20. And I am going to tell you right now, after more than 2 decades wrenching on these engines and watching them come through my shop with collapsed lifters and wiped camshafts, that number is not there because GM's engineers decided it was the best oil for your engine. That number is there because the federal government gave General Motors a financial incentive to print it. Let me take you back to 2013. That was the last year GM specified 5W30 oil for its truck V8 engines. Silverados, Sierras, Tahoes, Yukons, everything with the small block gas engine ran 5W30 from the factory. Then 2014 arrived. GM introduced the Ecotec 3-engine family, the 5.3-liter L83 and later the L84, and with it came a new oil specification, SAE 0W20 full synthetic Dexos 1 approved. GM's own service bulletin from June 2013 stated it plainly, 0W20 is the only oil approved for these engines. Every mechanic in the country started asking the same question. Why? What changed so dramatically inside this engine between 2013 and 2014 that required dropping to a grade of oil you would only find specified in small Japanese 4-cylinder cars? The honest answer is nothing changed inside the engine that required thinner oil. What changed was a number on a government spreadsheet. GM claimed 1/10 of a mile per gallon improvement in fuel economy for every drop in viscosity grade from 5W30 to 0W20. Spread that across 500,000 trucks a year, and your fleet average fuel economy numbers look meaningfully better on paper. That fractional gain helped GM comply with tightening corporate average fuel economy standards, the federal regulation that carries massive financial penalties for missing its targets. The 0W20 S-Spec was a regulatory compliance decision dressed up as an engineering one. Here is the proof. The 6.2-liter L86 engine in full-size GM trucks ran on 0W20. The 6.2-liter LT1 in the Camaro and C7 Corvette is the same long block, same pistons, same rods, same crankshaft, same valvetrain. GM specified 5W30 for the Camaro and allowed 0W40 for Corvette performance use. Same engine, different oil specs. The difference was not engineering. The difference was which vehicle needed to hit fuel economy targets and which one did not. Sports cars are exempt from CAFE calculations in ways that truck fleets are not. When you understand that, you understand exactly why your Silverado's oil cap says 0W20. Using thin oil in a V8 truck is only part of the problem. The bigger problem is what GM added to these engines starting in 2007 and expanded aggressively in 2014, active fuel management known as AFM and later dynamic fuel management known as DFM. These are GM's cylinder deactivation systems. When you are cruising at highway speed and not demanding full power, the system shuts off 4 of the 8 cylinders to save fuel. On paper, this sounds simple. Inside the engine, it is anything but. Every cylinder in a 5.3-liter with AFM or DFM uses a specialized 2-stage hydraulic lifter. These are not the conventional lifters from any pre-AFM small block GM engine. Each one has a spring-loaded locking pin inside it. When the engine control module commands cylinder deactivation, pressurized oil is routed through the valve lifter oil manifold, VLOM, which sits under the intake manifold, and pushes that pin inward. The inner and outer parts of the lifter decouple, the push rod goes dead, the valves stop moving, and the cylinder stops firing. When the computer wants that cylinder back, oil pressure releases the pin, the two halves lock together, and it fires again. This mechanical event happens thousands of times during a single commute, with precision machined components operating on oil film thicknesses measured in millionths of an inch. The failure that comes through my shop over and over again is the collapsed AFM lifter. The locking pin does not seat or release cleanly during a switching event. Sometimes it gets stuck partway. Sometimes the oil pressure feeding the VLOM is not adequate to drive the pin completely home. When the engine tries to operate with a lifter not fully locked in either position, the inner body slams against the outer housing under valvetrain load. That impact, repeated hundreds of times, destroys the lifter. You get a misfire, you get the tick, and if the metal debris from the failed lifter makes it into the oiling system, it wipes the camshaft lobe that was riding against it. That turns a lifter repair into an engine replacement conversation. Jasper Engines and Transmissions, one of the largest engine remanufacturers in the country, has documented this pattern in detail. They found that collapsed lifters are the effect, not the root cause. The actual root causes include mistimed command events from the ECM, oil viscosity, oil temperature, restricted orifices in the VLOM, and low oil pressure. Oil viscosity is on that list. It is not the only variable, but it is one that you, sitting in your driveway with a wrench, can actually control. Here is why viscosity matters specifically to these lifters. The locking pin relies entirely on oil pressure to move. The VLOM routes that pressure through tiny passages and solenoids to control exactly when each pin actuates. The whole system was calibrated around a specific oil viscosity because viscosity directly affects how fast pressure builds, how fast it bleeds off, and how cleanly the switching event happens. And here is the problem: nobody prints on the oil cap. Viscosity is not a fixed number. It changes with temperature and it changes with fuel dilution. Direct injection engines like the Ecotec 3 are known for blow-by that introduces unburned fuel into the crankcase. Mechanics performing oil analysis on these engines have found that 0W20 oil by a typical change interval has thinned below the minimum viscosity floor of a 30-weight oil. If the engine is programmed for a 20 weight and the crankcase is holding something closer to a 16 weight, those lifter switching events are not happening the way the engineers designed them to. That is exactly where collapsed lifters come from. I had a customer come in about 18 months ago, a 2017 Silverado 1500 5.3 liters, 74,000 miles. He had done everything right by the owner's manual. Oil changes on the General Motors oil life monitor schedule, always 0W20 Dexos, always at the dealership. He had the receipt stacked to prove it. The truck came in ticking on cylinder 7. We got into it and found a collapsed active fuel management lifter that had taken the camshaft lobe with it. Total repair, just over $6,000. He had done nothing wrong by the book General Motors handed him. The book General Motors handed him just was not written for this engine's long-term survival. The 2015 through 2017 model years carry the highest documented AFM lifter failure rates. But this is not strictly a mileage problem. Failures have been documented under 10,000 miles. They happen at 30,000 miles, at 50,000 miles, at 80,000 miles. The collapse can happen anytime the AFM system is active and conditions are wrong. What the data shows consistently is that the window before 60,000 miles is where prevention costs almost nothing compared to the repair. So what do you do? 3 things in order of commitment. The first is to address the oil. If your truck is out of the factory powertrain warranty, switch to a Dexos 1 certified full synthetic 5W30. The Dexos 1 Gen 3 specification is available in 5W30 from multiple brands. You get meaningfully better film strength at operating temperature, compared to 0W20, which is exactly what those AFM lifters need during switching events. If you are still under warranty, run what GM specifies. The moment that warranty expires, have a real conversation with a mechanic who has personally seen these lifters fail, not one reading from a service manual. Also, tighten your change interval regardless of what oil you run. The oil life monitor is calibrated for customer convenience and service department efficiency. It does not account for fuel dilution, lowering your viscosity below grade. 4,000 to 5,000 miles is the interval most experienced mechanics recommend for these engines. The sump holds 8 quarts, so changes are not cheap, but one oil change costs less than a single day of labor on a lifter job. The second option costs between $150 and $300 and takes 5 minutes. Companies like Range Technology make small plug-in modules that connect to the OBD2 port under your dash and signal the ECM to keep the engine in full V8 mode permanently. They do not reprogram the ECM and do not write to the vehicle's memory, so unplugging them returns everything to factory behavior. The trade-off is 1 to 2 miles per gallon, which is exactly the fuel economy GM was chasing when they introduced these systems. Paying for that gas yourself is a fraction of what collapsed lifters cost. If you use a disabler, understand the AFM hardware is still physically in your engine. The lifters, the VLOM, and the solenoids are all still there. The module simply stops commanding them to activate. The third option is permanent. An AFM delete means pulling the AFM lifters and replacing them with standard roller lifters, swapping the VLOM for a conventional oil pressure manifold, and having the ECM retuned to remove all AFM and DFM logic from the programming. Parts for a quality delete kit run between $1,500 and $2,500, depending on whether you upgrade the camshaft at the same time plus labor. What you get is a mechanically simple valve train with no cylinder deactivation hardware, built around the same basic lifter design that ran in GM small blocks for decades before any of this existed. Those are the same lifters in the pre-AFM Vortec 5300 engines that I have personally seen pass 250,000 miles on original internals. One more thing worth knowing before you hit 60,000 miles, the VLOM thimble filter. Inside the valve lifter oil manifold is a small plastic screen that filters oil flowing to the solenoids. It is easy to miss and almost never discussed in dealer service intervals. Over time, especially in engines that have seen extended change intervals or any internal wear, this screen clogs with carbon and debris. When it restricts flow, the AFM lifters are starved of clean pressurized oil exactly when they need it most. Cleaning or replacing it is a few hours of labor, and it is worth addressing around 50,000 miles if your truck has been running AFM actively. Here is the final piece, and it is the one that should put everything in context. When GM's 6.2-liter V8 started failing in enough 2021 through 2024 model year trucks to trigger a federal recall covering nearly 600,000 vehicles. The prescribed fix for engines that passed inspection was not a software update or a part replacement. It was a permanent oil viscosity change from 0W20 to 0W40. GM replaced the oil fill caps on those engines to reflect the new permanent specification. They moved those engines to a viscosity grade that is twice as thick at operating temperature, the same oil used in high-performance Corvette applications. That is not a minor adjustment. That is GM admitting officially and in writing that 0W20 was not providing adequate protection under real-world operating conditions. The 5.3-liter trucks were not part of that recall. But the same AFM and DFM architecture, the same hydraulic lifters, the same VLOM, and the same 0W20 oil are all present in those engines. The 6.2-liter recall established something important. When GM's engineers got the opportunity to specify oil for these engines without a fuel economy mandate forcing their hand, they chose thicker oil. Every time. If you own a 5.3-liter Silverado, Sierra, Tahoe, Yukon, Suburban, or Escalade built between 2014 and today, this is what I want you to do. Tighten your oil change interval, switch to Dexos 15W30 once you are out of warranty, put an AFM disabler on the OBD2 port, and have a mechanic inspect the VLOM filter around 50,000 miles. None of those steps are complicated. None of them are expensive relative to what they prevent. And not one of them is something GM was ever going to tell you, because doing so would cost them fractions of a mile per gallon on a government test. The 5.3-liter small block is still a great engine. I have seen pre-AFM versions of this same architecture run 250,000 miles without opening the valve covers. That durability is still in there. It has just been surrounded by a system that works against it. Now you know what that system is and exactly what to do before it costs you everything. If this helped, hit subscribe. I cover these engines every week without any dealership talking points in the way. Drop a comment below with your year and mileage. I want to know what you are running. Drive safe, change your oil, and take care of that truck.